Now let us solve this interesting proof. So here the information given to us is we have a right angle triangle where angle at A and angle at B are acute. So when angle A and B are acute, it's obvious that angle C will be 90 degrees because that is how we can solve for any trigonometric functions. We need a right angle triangle. Now also another information that is given is cos A is equal to cos B. So we will use this information as well. So in the end, the requirement is that we have to prove the angle formed at A and angle formed at B are equal. So that is our end goal. Now let's use the information given to us, which is cos A is equal to cos B. Now before we do that, let's draw a line D, CD, which is perpendicular to AB. So the angle formed here, these are 90 degrees. So CD is perpendicular to AB. So this gives us two triangles which can be used to find what the angles are at A and B. Are they equal or not? Now let's use the first information given to us, which is cos A is equal to cos B. So if we are here, cos A would be nothing but what is the adjacent. If we are at cos A, the adjacent would be AD, and if D is the right angle, so the hypotenuse would be AC. Same way cos B would be, if we are here, the adjacent side would be BD, and the opposite side of this 90 degree formed at point D is BC. Now if we interchange this, we will get AD by BD is equal to AC by BC. Now let's assume AD and BD or AC and BC actually had real values like 1 or 5 or whatever. So when we divide AC by BC or AD by BD, we will end up with some value. Let's assume that value to be K. So AD by BD is equal to K, and AC by BC is also equal to K. So this will give us AD is equal to K times BD and AC is equal to K times BC. So now we have these two equations which we will use further. Now let's look at these two right angle triangles. So we have to find the angles at B and angle at A. That is the proof that we have to achieve, that angle formed at B and A are equal. So to do that, let's apply the Pythagoras theorem here on both the triangles. So for this triangle, which is ACD, the Pythagoras theorem would be nothing but AC square is equal to CD square plus AD square, and for this triangle, which is CDB, the Pythagoras theorem would be BC square is equal to CD square plus BD square. So we have this information. Now now we see that in these two equations CD is common. So what we get is, let's rearrange, let's call this equation 1, let's call this equation 2. So equation 1 can be rearranged as CD square is equal to AC square minus AD square, and equation 2 can be rearranged as CD square is equal to BC square minus BD square. So basically we know what CD is. Now from equation 1 and equation 2, we can further write it as AC square minus AD square is equal to BC square minus BD square, because both end up with CD square. Now we have more information here. AD can be replaced with K times BD and AC can be replaced with K times BC. So AC, this will be K square BC square minus K square BD square, which is equal to BC square minus BD square. So here what happens is we get K square can be marked as can be taken as a common value between these two. So this will be K square, then BC square minus BD square, and BC square minus BD square. So this cancels. We'll get K square is equal to 1. So putting this value in the equation, if we find K square is equal to 1, we will get AD is equal to BD and AC is equal to BC. If we apply this here, if K is equal to 1, we will get AC is equal to BC, correct? Now, if AC is equal to BC, then the angle formed at B and angle formed at A are equal. So this is how we prove that angle at A is equal to angle at B.